Good evening. So after the completion of regenerative braking under this lecture number 21, we are going to see the battery management system requirements. So this is a PDF which is taken from Dr. Gregory's website. So what is meant by battery management system and what are the system requirements and some of the basics we are going to see in this 29 page notes. So the whole 29 page you will not have to study for your exam, but nevertheless you can prepare the whole thing for your knowledge sake. So what is battery management system? This is mainly it's an embedded controller based system, or embedded controller based control system rather, which is actually ensuring maximum lifetime and best performance from the battery. And as long as EV will be there, the research in the field of this battery management system, or BMS, it will keep on going on. And nowadays they are adding AI, ML, all those kind of algorithms, smart algorithm, genetic algorithm, fuzzy, for the better performance of battery management system. So let us understand what is battery management system and what are the functionalities. So you are finding this course. So Dr. Gregory is actually have launched a course. As per this course, we are going to investigate the proper management and control of battery packs, usually comprising many cells. So whenever I am saying battery management system, the system is actually is a battery pack. It is not a single battery. Because even if you see the car Tesla and other things, it's a huge number of batteries. They are connected in different configurations, and the configurations are actually dynamic, so that they can give best power supply to the vehicle for long range as well as for longer battery lifetime. So there are a lot of methods, there are a lot of circuits, there are systems, and there are a lot of algorithms that Dr. Gregory has explained in his class. So all these different algorithms can be implemented in BMS. So BMS is an embedded system. You can find purpose of this thing is to build electronics plus processing to enable a specific application. Application is best performance from battery, best power output from battery, and at the same time we should not load the battery too much. So we have to get maximum output power, but we should not stress the battery too much so that its lifetime will decrease. So protection and safety of the battery is also a very important thing that is ensured by BMS, as well as the devices safety, the operator safety. All these things are also seen at the same time. So this BMS actually detects the unsafe operating conditions and response. That means too much of power somebody is trying to extract from the battery, that is actually an unsafe condition. So we should never take the battery to the extent, neither while charging nor while discharging. So all those normalized operations are ensured by the BMS. So BMS actually protects the cells of battery from damage in abuse or failure cases. BMS actually ensures the longer life of the battery under normal operating conditions. BMS maintains a battery in a state in which it can fulfill its functional design requirements. BMS informs the application controller how to make the best use of the pack right now. So at present, whatever is the status of the charge, what is to be done so that battery will give maximum output to the wheels or to the motor without damaging itself. Sometime if we are asking too much power from the battery and the BMS is finding that its danger threshold is being exceeded, so BMS will rightfully tell the battery that okay, you cannot give supply to the tires or motors now. You better stop yourself discharging, and you better recharge yourself. And after recharging to a certain extent, then again you start getting discharged through the wheels. So all these very judicious decisions are taken from this BMS. So it is a kind of a brain. The BMS is having a brain, and the whole and sole importance of that brain is that it increases the lifetime of the battery, and it enhances the operating range, it enhances the lifetime, and it ensures the best battery performance at any situation. Okay, so even if the battery is discharged to a certain extent, then also it can be used if judiciously used properly, right? So it controls the power limit, it controls the charging discharging ratio as well. So there is a cost associated with the battery management. So not all applications implement all features. So sometimes we design a simpler BMS In that case, very highly intellectual decisions may not be able to take by the BMS. Okay, so depending on the brain, depending on the intelligence you are inputting in the BMS, the battery life will be extended directly proportional to it. So more amount of intelligence you try to inbuilt inside the BMS, it will ensure better operation, it will ensure higher lifetime. But BMS is not cheap. BMS is quite a costly device, because it's a total embedded controller based electronic systems, and there are a lot of algorithms, and the algorithms are continuously taking different kind of inputs. So they are taking inputs from brake, they are taking inputs from wheel condition, they are taking input from fuel inlet and how the fuel is flowing. They are getting different kinds of inputs from various points of the vehicle. Mixing all of them, they are ensuring that battery should work in the best condition, vehicle should be getting the best power supply, and at the same time it is increasing the lifetime of the battery. So there is a cost associated with the battery management. So not all applications might find it judicious or might find it cheap to implement all features of BMS, because BMS is costly. Huge amount of research is going on worldwide. So battery is cheap enough, but the BMS will be very costly. Okay, so if you cannot remember when last time the battery was replaced, so BMS can tell you that, okay, depending on the present condition of the battery, we can find the battery may be 3 years old. So there is a intelligence actually in BMS that makes it a special system, and nowadays every car is having a BMS, and BMS researches are going on to the full extent. Larger battery packs represent greater investment and motivate better battery management. Yes, so if the battery is giving out bigger power from many number of smaller units, in that case better control is to be designed, or better BMS is to be designed for that. So this PDF will focus on large, that is vehicular battery packs, although the method you discuss are quite general. So you are finding here that vehicular applications include HEV, PHEV, EREV and EV. What is HEV? It's a hybrid electrical vehicle. In that case, you will be finding battery plus one another source. So battery plus gasoline, maybe there may be gasoline plus fuel cell, there may be fuel cell plus battery. So those kind of things are there. So essentially zero all electric vehicle range it is there. Plug-in hybrid electric vehicle, this is called as a PHEV. It is larger battery than HEV, allows some all electric range under certain operating conditions. So plugged hybrid means the battery will be plugged and will be getting charged, and it is a hybrid vehicle. Extended range electric vehicle, so it is called as a EREV. Larger battery than PHEV, so it is extended range. That means in one charge it will go a very long range. So it is completely EV, but it is called as EREV, larger battery than PHEV. PHEV is plug-in hybrid electric vehicle. So wherever the charge is getting over, there you are plugging in and you are charging the battery so that you can go for further longer distance. So EREV is a higher version of PHEV. EREV is extended range electric vehicle. Okay, so it allows some all electric range under full load conditions. EV is electric vehicle, battery electric vehicle, BEV, that is another name. Battery provides the motive power. Motive power means for whatever power is required for the traction, battery only provides this. So all these vehicle types employ battery packs that are large, high voltage and high current. So all these batteries are supplying huge amount of power, that means high voltage, high current. Some distinction in design which we will detail when necessary. So other than large high voltage, high current, there are some other details also. Whenever the discussion will happen, there it will be explained. Commonalities more significant than differences. When distinctions are not important, we refer the whole class as XEV. Okay, so XEV means it is all these four things coming together, that is HEV, PHEV, IEREV, all those things together they are called as a XEV. That means main component is battery, and BMS is controlling the battery for its best performance. Another large scale application that justifies the advanced battery management is for grid storage and backup. So storage of the battery also, that is the input to the battery, is also controlled and judiciously done by the BMS, as well as the discharge or output from the battery is also done judiciously by the BMS system. What is the battery pack topology? So these are some of the questions. So we are going to see mainly 7 to 8 pages initial. You are finding here there are some batteries are connected in series. Okay, initially they are connected in parallel. So whenever the batteries are connected in parallel, their net voltage is the voltage of the highest battery. Okay, so whenever the batteries are connected in series, so depending on plus minus who is connected to what, the total voltage is the algebraic sum of the batteries. Algebraic sum means depending on the polarity you have to add or subtract the battery voltages. So that is what it is. Whenever the cells are in parallel, at that time whoever is having the highest cell voltage, that will be the output voltage of this cell. Okay, so whenever the batteries are connected in series, total current or net current is the maximum current from one battery source. Suppose there are three batteries, 2 volt, 5 volt, 10 volt. They are all connected plus to minus plus to minus. So net voltage will be 5 plus 3 plus 2, that is 10 volt when the batteries are connected in series. But what will be the total current? Total current will be, suppose the 2 volt battery was having maximum highest current output as 2 ampere. So whenever these three things are added, 2, 5 and 3, net voltage of the series addition will be 10 volt, but net current will be the maximum current of the three batteries, that is 2 ampere. But whenever the cells are connected in parallel, at that time what is the net parallel voltage of this combination? It is highest cell voltage out of these three. So if there are 2, 3 and 5, they are connected in parallel, in that case this whole combination will give you maximum output voltage of 5 volt. And what about current? Current of individual sources are added actually. Okay, so whenever they are connected in parallel, you have to remember that out of these three, whichever is the highest voltage, that voltage will be the overall voltage of this pack. And how to find the current? Current is nothing but addition of current from each of these cells. Now you are finding this is the parallel cell, this is the parallel cell, and this is the parallel cell. Such many cells are connected in series. As you are finding plus is connected to minus, plus is connected to minus. So first we have to find out what is the net voltage of this pack. So let's say x volt. X volt means out of these three, x volt is maximum, and one of these 3 volt voltage source is having x volt voltage. Suppose this second thing is having net voltage of the pack as y. That means out of these three, at least one battery source is having maximum voltage as y, and this y plus minus is connected to x plus minus. So whenever we are combining the series combination of these parallel sources, the net voltage will be x plus y. And how much will be the current? So in that current we have to see, we have to add the current of this 3, we have to add the current of this 3. Whichever addition is more, that will be the net current out of this 2 series parallel combination. So in this case they are saying 96 such cell groups, PCMs, are connected in series. Let's just go through. High power battery packs deliver high voltage, high current. Chemistry of individual cells, fix their cell range. Number of voltage pack, we must stack cells in series. So V pack is equal to NS into V cell. So whenever things are connected in series, 4, 5 such stacks, individual stack voltage multiplied by number of stacks is equal to the total battery pack voltage. Cell construction places limits on the cell current. So for high current packs, we must wire cells I pack is equal to NP into I cell. So whenever I told you that three things are in parallel, whatever is the net current is the total current of each, okay, given by each. Now such if there are 5, 6 things, we have to find who is giving highest current, which pack is giving highest current, that will be the total series current. So this series parallel design is generally determined by the economic and battery safety factor. Modules are usually kept less than 50 volt for safety, and then packs are kept less than 600 volt because power electronic begins to get very expensive at higher voltages. So maximum we can go up to 600 volt. Generally want to minimize the current to keep wire diameter small and reduce the resistive I square R wiring. Modules are minimized, NRE create reusable design. So there are 2 modules actually. This question is asked in the exam. Whenever there is a series parallel combination, explain which are the modules. So first one is parallel cell module. Okay, first one is parallel cell module. You can find here 3 parallel cells. So these 3 parallel cells. Okay, so this is called as a parallel cell module. So whenever there are 3 parallel cells, what is the net voltage? Highest voltage of these 3. That will be the net voltage. Suppose if 2, 3, 5 are in parallel, 5 voltage will be the overall voltage of this parallel pack. What is meant by series cell modules? So you are finding 1 pack, 2 pack, 3 pack, such many things are connected in series. So whatever will be the overall voltage will be addition of individual battery pack voltages. Okay, so we can design battery pack and BMS for either. Most often use something in between these examples. So module power and module energy both are approximately 18 into that of a single cell. So all these functions you can find out. So what is meant by BMS functionality? BMS functionality means there is a battery management system. The whole system is called as a battery management system. Cooling system, contractor control, pack measurement is also there. So continuously you have to find out how much is the battery or cell. Battery and cell both are same thing as far as my lecture is concerned. So whenever there is a cell, so this is called as a cell stack. Such many cells stacked together, it is called a cell stack, and cell stack is actually supplying the power to the vehicle motor control. But for individual cell we can measure current, we can measure voltage. So current is measured by CT, that is current transformer. Potential is measured for every cell by PT, there is a potential transformer. You can see internet to find out how does the CT and PT look like. And then the total power is given to the whatever is the motor input. So there the total voltage or power is given. That will generate the net output voltage, and that power should be given to the motor. So BMS is interconnected with all battery pack components and with vehicle control computer. So in this case you are finding this is battery management system, this cooling, contractor control, pack measurements, and this is vehicle control computer. So this is the main ECU, and here it is battery management system is a sub ECU, but the sub ECU is controlled by the vehicle control computer. So functionality can be broken down into several categories. Number one, sensing and high voltage control. So I told you there is CTPT, there is current transformer, potential transformer and all, charge transformer, discharge transformer. Continuously this transformers or sensors, they are actually sensing what are the high voltage, high current, power and all those things. So measure voltage, current, temperature. Yes, temperature is a very important thing, because at high temperature the battery reaction becomes so high that it creates kind of a traffic jam and battery output voltage reduces. When the battery is too much at cold, at the time cold cranking, again the battery reactance or reaction does not happen fast. In that case what we find is battery output voltage is less. So sensing the high voltage and control, measure voltage, current, temperature, control, contactor, pre-charge, ground fault detection, thermal management. So these are the jobs of battery management system. Protection circuits, protection against overcharge, over discharge, over current, short circuit, extreme temperatures. So protection circuit is not shown here. You can put another block and you can show that there is a protection circuit, protection against overcharge, over discharge, over current, short circuit, extreme temperature, etc. Because you cannot lose a car because the car is too costly compared to the battery management system. So if it's a very high-end car, battery management system should be very sophisticated. What is meant by protection against? We have seen. Then we are going to see interface. It is called as a range communication, data recording, reporting. So what all different facets are connected to this BMS and through which they are connected. So it is range estimation, communication, data recording, reporting. These are the main interfaces. So data recording means there will be a recorder, reporting means there will be a report generator, communication is also there. So in vehicle there is a part called as a infotainment, that is information and entertainment. That means it is an extended part of IT, that is the information technology. So there actually the different interfaces are there. Range estimation, so there will be a sensor, communication there might be antenna, data recording there will be a recorder, reporting again there will be antenna. So these are different interfaces or added facilities in the vehicle. So even if there is no communication, no range estimation, no data recording, then also the vehicle will run and run properly. But as it is very high smart BMS, in that case we also can assume that, or we can understand that the vehicle is of a rich man's vehicle. So in that case this interface related things must be there. Next we are finding is performance management, state of charge estimation. That means how much state of charge is remaining inside the vehicle. I think I had given you that formula, so lecture is uploaded, you can check. So power limit computation, balanced equalized cells. Balanced equalized cells means if there are 300 cells inside the vehicle, we try to keep each vehicle at same voltage level and same current level, so that query can be fired to the vehicle from any direction, but then also vehicle should be able to answer it. So performance management, state of charge estimation, power limit computation, balance, equalize cells, diagnostics. Diagnostics means abuse detection, state of the health estimation, state of life estimation. That means if there is something, anything wrong inside the vehicle should be able to understand it by its own sensor array, and it should be able to decide, and it should be able to tell the ECU that this part of the vehicle might not be in full capacity or might not be working to its full extent. So knowing one's own health is the most important thing for proper diagnostics. So in this chapter, or in this 29-page document, we address some of the more basic but important design considerations. Later we'll develop the management and diagnostic topics in detail. So mainly we are going to study about different sensing technologies in BMS. First one is battery pack sensing. In battery pack sensing, what all things we sense is voltage. Okay, so it is assumed that it's a lithium ion pack, that means lithium battery. Whatever things we are measuring as voltage, SOC, SOH, state of charge and all, state of heat and state of charge. Overheating a lithium ion cell can lead to thermal runaway. Whenever there is a thermal runaway, there is a possibility that the battery will burst. Okay, so we cannot help that thing happen. That means thermal runaway means build up of temperature inside the battery, so we cannot help that. So special chipset are made to aid high voltage BMS system. It is using low cost dumb measurement chips. It is using special chips implemented who are implementing actually difficult tasks. It can often be replaced in parallel and redundant fault tolerant designs. Number of vendors make chipsets including analog devices, Atmel, Intercell, Maxim, O2 Micro, Texas Instrument, etc. So you can just go through. Next is we are going to see first sensing of battery, and after that we are finding temperature. So inside the BMS, battery pack operational characteristic and cell degradation rates are very strong functions of temperature. That means if we find that some battery is degrading very fast, or untimely death of the battery, that means death means it starts operating, it stops operating, or it stops generating output voltage. In that case we understand that yes, definitely there is a something wrong going on inside the vehicle. And one very wrong thing that might go inside the vehicle is very high temperature. So ideally we measure each cells in internal temperature separately as well as in a combined manner. So there is thermistor, there is thermocouple, NTC, PTC, that is positive temperature coefficient, negative temperature coefficient. What is NTC and what is PTC? PTC means if temperature is increasing, its resistance also increases, like a thermal wire that is having a PTC. What is NTC? If the temperature increases, resistance of the sensor decreases. So in case of semiconductor we find this, that is called as a NTC. So there are different kind of sensors who senses the temperature inside the BMS system or inside the vehicle. Depending on the cooling system is actually designed, sometimes we find air cooled, fluid cooled, oil cooled system. Different types of systems are there. Depending on too much heat produced, we cannot use air cooled system if there is too much of heat produced inside the vehicle. So in that case we need some oil cooled or some liquid cooled fluid system there. Okay, so thermistor dataset. Thermistor is a NTC kind of a thing. Then we are finding battery pack sensing. So we are still sensing. First we sensed voltage, now we are sensing current. So for current sensing it is called as a CT. There is a current transformer. Second parameter we sensed was temperature. Third parameter we are sensing as CT. So why current measurement are required? To ensure safety, to log abuse condition. Abuse condition means somebody is torturing the battery, so too much of power is being extracted and all. So what was the torture, or what the torture is being done to the battery? To ensure that actually we have to measure the current inside the battery, or how much current is produced by the battery. So by most state of charge and state of the health algorithms we can find out what is the state of charge inside the battery. So there are two basic sensing methods, shunt and Hall effect. So shunt means we are putting a smaller shunt resistor in parallel with the actual resistor, and we can find out how much is the current. So it's a 4-wire voltage measurement kind of a thing, Kelvin connection. So it's a bridge balance kind of a thing through which you can find how much is the current produced by the battery. And Hall effect sensors measure the magnetic field generated by current flowing through a wire, and through this, by Hall effect, that is a combination of electrical as well as mechanical effect, we can measure how much is the current produced by the battery. So requirement, high voltage contactor control. So whenever we are saying it's a battery, there will be contact with the high voltage circuit. how to control the contactor of the vehicle. So pre-charge contactor activated next. So these two topics will not be asked in the exam, but then also you can just go through for your own knowledge and all. Requirement of isolation, sensing and thermal control. So why isolation sensing is required, it is given here. So what is meant by isolation, that you have to know first. What is the necessity of isolation, you can find out. This mathematics you can avoid. And there is thermal control. Whenever I am saying thermal control, first there should be a thermal sensing. What are the different thermal sensors are there, we have discussed initially, and why thermal control is required, that part is explained here. Then protection interface. Under the protection, we are finding BMS must provide monitoring and control to protect cells from out of tolerance ambient operating conditions. So these first two lines are very important. What can be the most adverse conditions on the BMS? So first is out of tolerance ambient operating conditions. Second is users from consequences of battery failures. So one is battery is almost going at the verge of failure. Second one is what the users will do where the battery has already failed. So high energy storage batteries can be very dangerous. So we can say that yes, we can increase the energy storage of the battery pack, but yes, whenever you are increasing high energy storage battery pack, they themselves can act as a bomb in case of a vehicle. Different applications and different cell chemistries require different degrees of protection. Yes, depending on the chemical you are using, type of battery you are using, you have to enhance the protection in some cases. Protection must address the following undesirable event or conditions: excessive current during charging, discharging, short circuit, over voltage, under voltage, high ambient temperature, overheating, loss of isolation, abuse. All these things are actually evaluated during designing the protection circuit for the BMS system. So I think this much is enough. So charger controllers, you can see communication via CAN bus. So CAN bus is one protocol by which machine to machine communication or device to device communication can happen. So these are the things that I could explain to you at your level, but main questions that can be asked in the initial part, that is what are the functionalities of BMS. This is one question, very important question. What are the different vehicular applications? So you have to explain this 4. What is meant by battery pack topology? So these two topologies, series, parallel series. BMS functionalities, this block diagram is very important. And then there is current sensing, voltage sensing and thermal sensing. So these are the things that you prepare for your BMS, and you can check different internet websites. You will be finding enough material on BMS. So this finishes the BMS lecture. These notes will be uploaded. At the same time, the PPT which was taught just before this, that also will be uploaded. 2 videos will be uploaded for braking mechanism of the vehicle. Okay, and this finishes the module number 3, and this finishes the lecture number 21. Thank you.